Okay, so here's a sequence. Now, what you notice about this sequence, unlike the other arithmetic sequence we've been looking at, you can see that the difference between the terms is not constant. It's not the same. The difference between these two is 7, and the difference between these two is 14, and then 28. So the difference is actually changing. So this is not an arithmetic sequence. This is what we call a geometric sequence. Now, how do we know if it's a geometric sequence? Well, a geometric sequence, instead of having a constant or common difference, has a constant ratio between the two terms. Okay, so this ratio we call R, and R is found by getting a term and dividing it by the term before it. Okay, so you can pick any term and then divide it by the term immediately before it in the sequence, and that will give you the common ratio. So in this sequence, let's pick the first two terms here, okay? So the ratio would be 14 divided by 7, and that is 2, okay? So you can check if this is a common ratio by picking any two terms. So let's pick these two here. I could say, alright, so the ratio must be 56, and all I do is I just divide it by the term immediately before it. 56 divided by 28 is 2. So this sequence has a common ratio between all of the terms. 28 divided by 14 is 2. 112 divided by 56 is 2. Therefore, that's what makes this a geometric sequence. Okay, so you're looking for a common ratio, not a common difference. Let's take a look at another sequence. Let's do 48, 24, 12, negative 6, 3. Okay, so let's say we've got a sequence here, and we immediately notice it's not an arithmetic sequence because the difference is different. So let's figure out what the common ratio is. So the common ratio is I pick a term, so let's pick negative 24, and I divide it by the term immediately before it in the sequence. So that'd be 48. That gives me a common ratio of negative a half. Now we can check this. Pick another two terms and say, alright, let's do negative 6, divide it by the term immediately before it, it's 12. That also gives a ratio of negative a half. So this is a geometric sequence because each of the terms share a common ratio of negative a half. Okay? The way I could get to the next term is multiplying a term by the common ratio. Okay? So 3 multiplied by negative a half. So that would be the next term in the ratio.